Hey class, it's just me, Mr. Wee. I'm just gonna go over. Let's see, sorry about this. Got some stuff here. Some joking. I just want to go over the last section. Actually, ever that we're gonna go through, or at least in this class. Um, open up the screen here. It's gonna be 11-9. Areas of circles and sectors. And if you remember, sorry, it's a little crooked here, my writing. If you remember, the area of a circle versus the circumference of a circle are two very similar formulas. I think you've learned previously it's pi times r squared, and this is 2 pi r, or 2 times the diameter. Or sorry, 2 times the diameter. Or I'm sorry, not 2 times the diameter. Mr. Wee's getting crazy. Sorry about that. It's pi times the diameter. But why is that? So you might want to know. Well, let's take a look at a circle really quick. So I'm just going to go over sort of like the theory behind this. So let's pretend that this is a circle. It's a diameter. And let's cut this about, I don't know, like a few slices. Let's do like let's see, that's the center. So let's touch the center. So 1, let's see, 2, 3. I don't think I'm going to do this perfectly. Let's see. 4, 5. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we got 12 slices of this circle. And let's say if we were to rearrange, so you know that all of this would be this circumference. Let's see, if you the circumference would be the perimeter around this circle. That's the circumference, which we know is equal to 2 pi r, right? If you think about it, and you know that this is the radius, right? Each of these slices is the radius. Well, let's take a look if we rearrange these guys, these 6 slices. So let's take the 6 slices here, and let's rearrange them in sort of what looks like a parallelogram, or so it's 1, 2, 3, 4. So these 6 slices are being removed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Imagine if I made sort of like what looks like a parallelogram. It kind of looks like a parallelogram, right? And it should be. I know this length, each of these lengths here are basically the individual cuts of the slices. There are length long. And if you think about it, what used to be on the outside, on sort of like the backs of these slices here, all the way around is the circumference. It's like the perimeter of the circle. Well, here, they're all on the outside here, and the other half is over here. So if you think about it, each of these sides is like 1/2 the circumference long. It's just, this is a half of the circumference, the other half is over on this side. What would be the area for this? Well, the area would simply be length times width, right? And in this case, our length would be r, and our width would be 1/2 of the circumference. If we go back to what our circumference is and talk about everything in terms of the radius, it'd be r times 1/2 2 pi r. And if you look here, the 1/2 and the 2 cancel out, and you'd be left with pi, or r times pi times r, which coincidentally, or not coincidentally, is pi r squared. Okay, so that's the derivation for this circle, or the area of the circle. That's where we get the area of the circle. Okay, so that's the first part of this easy section. If you think about it, the next part is, what if we were given, I'm going to go through a theorem basically. Let me see if I can, whoops. Go through here. Let's go through another theorem that's in your book. going to be pretty simple. Well, you know what? We'll go with an example first. So here's the example that's in your book. So you got a pizza, a circular pizza. It's a circular pizza. I think this book was written at the time where they were advertising pizza from Domino's that wasn't circular. I digress. Anyways, we have a circular pizza that has a diameter of 12 inches. Okay? There's 8 slices. 8 slices. What is the area of one slice? There's 2 ways you could solve this, but let me just show you one way, okay? So a lot of you guys might be pretty good at this. This is 12 inches across, right? The pizza. And if you cut that up, let's see, that's 8 slices. That's the center. That's 1 slice. Let's see, 2 slice. Let's see, 1, 2, 3, 4. Yep, I think that's 8 slices right there. Okay. Well, you know that if the diameter is 12, the radius must be 6 inches. And if you do the area of the whole circle or the whole pizza, that'd be pi times the radius squared, which would be pi times 6 squared, which would be 36 pi inches squared. That's the area for the pizza. And then some of you guys could actually just do it pretty simply. Let's see. You would just take this here, and then we would divide this by 8. Okay, which would give us roughly about 36 divided by 8. Actually, we could just leave that there, and then let's actually see what that looks like. Let's do a quick calculation. I actually have a TI-83 on my computer. How crazy is that? Right? So we just write 36 pi. Let's see where my pi sign is. I can't ever find this. It's kind of hard for me to see on here. Where's the pi? Must be so old. Let's see if I can't find it. Okay, it's not here, so let me clear out of here. Shoot, where's pi? It'd be times 3.14 roughly. It's 113, and I divide that by 8. So I can do it like this way. So that would give me about 14.3 inches squared for one slice. The way that they show you in the book, let's see. Well, actually, I'm sorry. The way they show you in the book's a tad bit different. The theory behind this is you could have solved this without having to divide this up into 8 slices. Or let's add an additional question. What is the degrees at which each of these slices are? So if I knew that, let's say if I wanted to do this a different way, first I would ask you how many degrees is in each of these pizzas. What does that mean? Or what is that going to look like? You would just take 360 degrees, you divide it by 8 slices, or 8, and then you know that each of these guys is 45 degrees in terms of a cut, 45 degrees, right? And then what you would do is you would set this up as a proportion. Since you know that each of these guys is 45 degrees, you do 45 over 360, and then you'd set that up equal to the area, the total area, which is 36 pi, and then set it up as proportion, 2 ratios, and you don't know. So this represents in degrees how big was the slice, and then you're going to see how much it is equivalent in terms of what the area is going to be, what the area of that exact pizza is. So I guess this way this acts as a check to see if you did your work right, but this method is actually very useful in different contexts. So here you would just cross multiply. So let's see, I think that would be 36 times 8. So, or 36 times 45. Let's do that. Save yourself some time. 36 times 45. That's 1,620. Pi is equal to 360 x, and let's divide both sides by 360. So what I'm going to do is I'm going to multiply my last answer by 3.14, which is pi, and divide that by 360. There you go. It's the same answer. 14.13 inches squared is going to be the area of the that individual slice. So basically what we just went through was a key concept in your book. This is on page 785, I think just about 785. So the proportion is, it's generally the area of the slice that you're looking at divided by the area of the whole circle. You set that as a proportion equal to the amount of degrees that you're looking for over 360 degrees. That is, and if you just want to find the area of the area of the sector, you'd basically multiply both sides by pi r squared. So this is, I like just setting up as a proportion. Don't worry about the equation. This is the actual proportion you want to set up, and then you just solve from there. All right, guys, that's actually it. There's not much else to this section. It's really quick. So have at it, have fun, and you guys have a great and wonderful day. Bye.